Have you ever wondered, how do astronomers actually know how fast the moon moves? Or how fast the sun and the planets travel through space? And what about the distant stars and constellations? Can we really measure their speed? Let's explore this. Hello there, welcome back to Star Stuff, where we find out some cool things. Today we're breaking it down in a way anyone can understand. And if you're someone who doubts space, or you've heard flat earth conspiracies that say, how could they possibly know that? This video is for you. Let's start with the moon because it's close and it's easy to measure. Astronomers track the moon's position against the background stars night after night. By using simple geometry and timing how long it takes to complete an orbit around Earth, which is about 27.3 days, and knowing the moon's distance, which is measured with laser reflectors left by the Apollo missions, we can calculate its speed. And we all should know speed equals distance traveled divided by time. The moon travels about 1.02 kilometers per second, or roughly 3,700 kilometers per hour around Earth. That's not theory, that's mathematics based on direct observation. Now, what about the sun and the planets? We know how far Earth is from the sun, which is about 149.6 kilometers, and we know it takes 1 year to complete an orbit. So again, distance around the orbit divided by time equals speed. Earth's orbital speed? About 107,000 kilometers per hour. We do the same for the other planets, using radar ranging, spacecraft flybys, and observations over centuries. It's not a guess. These calculations are confirmed every time we send a probe like Voyager, Juno, or Mars rovers on a precise trajectory. If we don't know these speeds accurately, these missions would miss their targets by millions of kilometers. Come across tons of space deniers and flat earthers who say the same thing over and over again, and it just confirms how much they don't know.
How is it that the world is endlessly spinning through a galaxy, 1,000 miles an hour at the equator, 66,000 miles an hour around the sun, chasing the sun through the galaxy, 500,000 miles an hour, forever and ever and ever, but the stars look like this? But, you know, throw that and logic aside, because we're apparently endlessly spinning, never ending, never stopping, never going to the same place, just forever and ever and ever, cycling endlessly crazy through the galaxy.
Even though we're spinning on Earth about 1,000 miles per hour, which is pretty slow considering the size of the Earth, by the way. This amount every hour. We're orbiting the sun about 67,000 miles per hour, which takes 365 days, by the way. And the sun itself is moving through the galaxy about 500,000 miles per hour, which takes 225 to 250 million Earth years, by the way. The stars are so far that from our point of view, their positions barely change over thousands of years. The sun looks like it moves daily because we rotate every 24 hours, and it shifts through the year because of our orbit. And that's all nearby compared to distant stars. A star's light isn't fixed. It just appears fixed because the change is too small for our eyes to notice over a human lifetime. Astronomers can measure that tiny change, which is called proper motion or parallax, but it takes very precise instruments and many years of observation. That's why the night sky looks stable even though we're moving fast. Astronomers use two clever methods. The first one I mentioned, proper motion. By comparing photographs taken years apart, we see tiny shifts in stars' positions. With the distance known, that tiny angle becomes a speed across space. And the other way is a Doppler shift, spectroscopy. Light from a star works like sound from a moving car. If it moves towards us, its light is slightly shifted toward blue. Moving away, shifted toward red. Measuring that shift tells us how fast it's moving along our line of sight. Even the stars in the Orion constellation have measurable speeds, often tens of kilometers per second, detected with high precision instruments. And some people say, you can't know that, space isn't real. But these speeds aren't just made up numbers from textbooks. They're confirmed through repeated observations over hundreds of years, laser ranging experiments, spacecraft navigation that would be impossible if these calculations were wrong, and even amateur astronomers with backyard telescopes can track these movements. If you deny all that, you're not just denying space or NASA. You're denying simple mathematics and direct evidence anyone can check. So next time you hear someone ask, how do they even know how fast the moon or the sun moves? Remember, it's not magic, it's not fake, it's careful measurement, geometry, and physics that anyone can learn. Space is actually real. And the more you learn, the more amazing it gets. If you enjoyed this breakdown, give it a like and share it with anyone who needs it. And please subscribe for more clear, simple explanations about our universe. Thank you for watching. Cool beans.